Hi everyone, this video is going to go through Chapter 1, Section 1.1, which is on the coordinate system. This video won't be too long or lengthy because there's mostly review again in Chapter 1. So the coordinate system, first of all, basically is this set of axes. And some things you should remember is that this happens to be your x-axis. This represents your y-axis. The origin is where those two things cross. That is called the origin. And this divides the plane up into 4 regions. These regions are called quadrants. Quadrants, so I'll write that down here. And they are numbered using Roman numerals, and they happen to go counterclockwise. So this is quadrant number 1, quadrant 2, quadrant 3, and quadrant 4. Okay, and what this plane is used for is to help us plot graphs, draw graphs, plot points. So in this section we just want to remember how to plot some points. So I'm going to do the point 1, negative 3. And in order to do all those things, I'm going to put a scale in here. If you want to use graph paper, feel free to do so. I usually save graph paper for when I need to do really detailed graphs. And right now, I'm just going to kind of eyeball it here. So the point 1, negative 3, first of all, it is alphabetical, so this is your x and that is your y. So 1, 3 is 1 on the x, and then 3 on the y value, and it would go right there. We'll do one more for good measure. So let's do negative 2, 5. So negative 2, 5, again, this is my x, this is my y. Negative 2, and then 5 would be 1, 2, 3, 4, 5, all the way up here. So if this was point A, and this is point B, A is down here, and B is up there. All right, let's consider 2 points. All right, so I have the 2 points, negative 1, 7, and another point, 5, negative 3. And I'm going to try to find the distance between those two. So there is a formula, but I want to make sure you understand kind of where this formula comes from. So I'm going to draw these 2 points, negative 1, 1, 2, 3, 4, 5, 6, 7, and 5, 2, 3, 4, 5, 2, 3, negative 3. So there are those points. Okay, and we are going to find the distance. So the distance, and when we talk about distance, we mean the straight line distance between those two. To calculate where this formula comes from, imagine a perfect triangle here, the right triangle. Okay, and if you can remember, probably one of the most famous theorems that you have in your head, Pythagorean Theorem, is that a squared plus b squared is c squared. So it comes from that, a squared plus b squared is c squared. Or if c represents that distance, taking the square root, a squared plus b squared. Now, we don't have to worry about a plus or minus because distance is always considered to be positive. Now what we need to do is figure out 2 ways to represent a and b. So how do we find the length from here to here? So that is going to be the change in those x values, or I'm sorry, in those y values. So that's change in those y values, how we change from here to here. This guy is going to be the change in our x values. How did the x values change from here to here? So the distance between those two. And if we think about change, or distance between two things, we're going to subtract them. So if we want to do the x's first, we can take x1 minus x2 to find out how far apart they are. And we have to square them because of the Pythagorean theorem. And then we're going to do the same for those y values. And we square those. It will not matter which way we subtract, simply because we are squaring it, and so that's going to undo the negatives and things of that nature. So for this example, we can take our x values, and we can do that 5 minus a negative 1. So 5 minus a negative 1 squared, plus my y's, then that negative 3 minus 7 squared. So this gives me 6 squared, which is 36, plus this would be a negative 10 squared, or 100. So we end up getting the square root of 136. We can see that here as well. So here, if you want to talk about the distance from here to here, it's 7 and 3 more, that's 10. Notice we did get the 10 there. Here is my 1 and 5 more, there's that 6 that we found. So you can see it in the picture as well. And of course, we could get the decimal approximation for this guy using our calculator. The last thing I want to talk about is how to find the midpoint between these 2 points. So where is that midpoint? I'm going to guess, I don't know, it's probably somewhere there, maybe a little closer to this guy. Okay, so midpoint or middle, the way we find it is we average our x's. So we're trying to find that average x, and we also want to find that average y. So average is you add and divide by 2, and we're going to do the same for our y values. So here we're going to take that negative 1 plus our 5 divided by 2, and our 7 plus that negative 3 divided by 2. Or 4 over 2 and 4 over 2. So the point 2, 2. That's pretty close. My scale is a little off, but if I had drawn it on nice paper, I'm sure it would have looked a lot better. But these are for just a few things from that chapter 1, section 1, talking about that coordinate system, bringing some of those things back to light, and a few things that were probably a little rusty. The midpoint tends to be one that most students forget. Distance, they remember somewhat. But hopefully now you can remember thinking Pythagorean Theorem. I still sometimes like to draw pictures to help me. But as we get further into the course, we're going to need to remember some of these things. So hopefully they will be back in your brain, sharp as a tack when we need them.